Hello everyone, in this video we will see the preparation reactions of alcohols. This will be the part 1 of this particular preparation reactions of alcohols. I will cover few more reactions of this particular alcohols in my next video. That will be in part 2. So now let's see one by one. Now let's see first reaction, that is hydrolysis of alkyl halides. Let's see with one example. If you take any alkyl halide here, let's take this primary alkyl halide, right? And in the presence of this aqueous KOH, can use this reagent, that is aqueous KOH. Then it undergoes this substitution reaction. Whenever if we use aqueous KOH, it undergoes substitution reactions, and if we use alcoholic KOH, then it undergoes elimination reaction. This is very important. I have already told it, right, when I have discussed in maybe hydrocarbons. So yeah, it's just substitute in place of this chlorine, just substitute the pH. Let me write it over here. Important. If it is aqueous KOH, it undergoes substitution reaction, right? And in case if it is alcoholic KOH, it undergoes elimination reaction. So yeah, I hope it's clear. This is the hydrolysis of alkyl halides. If we take any alkyl halide, take aqueous KOH, then just replace this chlorine with OH. We can look at the alcohols like this, or else we can take another. We can take different reagents also. See here, over here we can take different reagents like NaOH, or we can also take moist Ag2. So yeah, these are all the different reagents we can use over here to prepare alcohols from alkyl halides. So the next method is from alkenes also we can prepare alcohols. Let's see one by one. Here there are few different types of reactions are there. Already discussed these all the reactions in hydrocarbons. Let's just revise once again in this. From alkenes we can prepare this alcohols. First method is acid catalyzed hydration. So yeah, let's see one example. See here, acid catalyzed hydration is simply addition of water, H2O, and here the conditions are the addition of this water according to Markovnikov rule, writing MR Markovnikov rule, and here in this case rearrangement of carbocation takes place, right? Rearrangement of carbocation takes place. So these are the requirements. Like in this reaction, if we take any, let's take one example. So if we take this one, this particular alkene, first let's take this H plus, right? Form carbocation first. Here again I am explaining you with mechanism that will be helpful for you, right? This is the basic mechanism. Here it will form carbocation. Now there will be a rearrangement. Now there is a rearrangement occurs because as we know that this is a secondary carbocation, right? This is a secondary carbocation. There is a possibility of getting tertiary carbocation also because here one hydrogen is there. If you do 1,2 hydride shift over here, you can get the tertiary carbocation. Let's do that. So just shift this over here. This is 1,2 hydride shift. We are doing 1,2 hydride shift, right? So here there are methyl groups and hydrogen also. You just need to, if you compare the migratory activity for hydrogen and methyl group, hydrogen has a migratory activity. So yeah, first hydrogen will be migrated rather than the methyl. So now we'll get this tertiary carbocation, right? I've got tertiary carbocation. This is more stable than secondary, right? This tertiary. Now let's add water over here. Hydrolysis for this particular one. Get this tertiary. So I hope it's clear, right? Simple mechanism here. And the next one is simply here what we are doing. This is simply addition of water. And according to Markovnikov rule, where in case if you have any doubt in Markovnikov rule, just let me know in section. I'll explain you once again. I'll make one more video that particular one. And here rearrangement of carbocation also takes place, right? The next reaction is oxymercuration denaturation. Let's see here this reaction. This reaction is it, this is also simply addition of water takes place. In this also simply addition of water, and we will write the product according to Markovnikov rule. And one more condition is that here there will be no rearrangement takes place. Rearrangement takes place. This is the one important thing over here. For rearrangement, carbocation rearrangement takes place. Right. So in this case, acid catalyzed hydration, I have told you, right? Rearrangement of carbocation takes place. But in this case, the difference between these two reactions are in this these two will write according to Markovnikov. But the thing is that in case of acid catalyzed hydration, there will be rearrangement of carbocation is possible. In case of this OMDF, you can also call it as oxymercuration denaturation. In this case, there will be rearrangement takes place. So up to here, I hope it's clear, right? So now let's take one example. Let's take same example we have taken above. Then you can easily differentiate, right? So yeah, let's take the same example over here. The reagent is let's take the same example. The reagent is HgC twice H2O and H4. H4 presence of basic medium, right? So yeah, I have told you this is also simply addition of water according to Markovnikov rule without any rearrangement. So yeah, here simply will add OH over here. Simple product we have got. So I hope it's clear, right? So this is the product we will get. So yeah, now let's see this hydroboration oxidation. So it's HB short for hydroboration oxidation, right? So yeah, now let's see one example over here. For that, let me tell you. Here this will write. This is also simply addition of water. Simply addition of water. Simply addition of water. Right. H2O simply addition of water, and we'll write this product according to antimer. I'm not writing all the, so yeah, this is write the according to antimer and this is the different point here. Write the product. It's also simply addition of water, and we'll write the product according to antimer. So now let's take same example for the also by seeing generally easy mention this, right. So yeah, the reagent is here H3 H2O2 so basic medium. So yeah, this is simply addition of water according to antimer. So the product is our final. So write it. This is our right. So I hope you can differentiate these three reactions. Even though we have already discussed these in hydrocarbons, we can prepare alcohols, that is dehydroxylation. So let's take one example. If we take simple alkene, take simple alkene, presence of this H2O, or else we can take this Bayer's reagent also, that is KMN. This is called dilute KMN. This is also called as Bayer's reagent. Bayer's reagent. Called Bayer's reagent, right? So we'll get simply this is syn addition. Like it undergoes syn addition and we'll get this product. Right. So syn dihydroxylation. These two are syn reagents. Or you can also call cis reagents. These two are cis reagents. These two are cis reagents. Right. We can use OSO or else we can use this Bayer's reagent. So yeah, it's clear now. Let's see this. One more reaction that we can prepare alcohols, that is using Grignard reagent with aldehydes and ketones. So see this now. So let's take one formaldehyde. Take formaldehyde. If we take formaldehyde, then let's take Grignard reagent. That is, let's take this symbol CH3 This is a Grignard reagent, right? So yeah, this acts like a nucleophile and that acts on the carbonyl carbon. So that act on the carbonyl carbon and will plus CH3, right? And then after that, if we do hydrolysis for that, simply we will get CH3, CH2, H. See what we have got here? We have got primary alcohol. We have got primary alcohols. First we took this formaldehyde. This is formaldehyde, right? Let's see if we take formaldehyde, what we get. We can prepare primary alcohol, secondary alcohol, and also we can prepare tertiary alcohol. That's what I'm trying to explain here. We take formaldehyde, we can prepare primary alcohol. So now take this aldehyde. From this we will get secondary alcohols. Let's see how. This is very simple mechanism, right? This acts like a nucleophile and it attacks on this carbon, right? And will form a CH3. If you do hydrolysis over here, like that, in step-wise hydrolysis, then simple COH H CH3. This is the secondary alcohol. When you take only formaldehyde in the presence of this Grignard reagent, then we'll get primary alcohols. Right. And then if you want to prepare tertiary alcohols, we need to take the ketones. Let's take the simple that acetone, right? So in this, take this CH3 MgBr and this hydrolysis. Same mechanism, right? It attacks carbon and carbon, bond shift towards oxygen. Yes. After doing hydrolysis, we'll get tertiary alcohols. CH3, CH3. This is the tertiary alcohol. So yeah, these are the preparation methods we have discussed in this video. So in my next video, I will try to explain you few more preparation methods for alcohols. So that's it for this particular session.